Welcome to the CER tutorial, Physical Science 2 Learning Set 2. And so this is the reasoning portion of it. So if you're doing this part and this part only, that means you did really good on the claim, you did good on the evidence, but you need to brush up on your reasoning. Now the good news is reasoning, if you know some of the tricks behind doing well in the reasoning, it gets a whole lot easier. But it is the hardest part. Now the reasoning shows how or why the data counts as evidence to support the claim. So it actually takes the evidence and it helps explain why the evidence supports the claim. It provides the justification for why this evidence, again, is important to the claim. It includes one or more scientific principles that are important to the claim and evidence. Now, there are a few times where when we write CERs where there is no scientific principles. You know, if we don't provide them for you, you don't have to have them. But in this case, you were provided a whole bunch of scientific principles. And this is one of those things. I would probably say the number one reason why someone got a 1 on the reasoning is because they provided no scientific principles. And keep in mind, I reminded each of your classes that you should have scientific principles before you took the CER. And I always point to the back of the room and say, look, there's posters back there. You can use those posters. I don't care if you get up out of your seat, go back there and reread the posters before you hit submit. And on the reasoning one, it says, use scientific principles. So if you don't use scientific principles, I'm really baffled as to why, because I remind you to in the beginning, and I tell you to use the posters, so you have both those reminders, but yet some of you still don't do it. So that's a quick way to improve your reasoning really fast. Now, first of all, here are the scientific principles. So if you watched the claim one, we've already gone through this once. If this is your only one that you have to do, we'll go through it again. So what I'd like to do is I like to go through here. Oops, forget that little green there. I can erase that. What I would suggest is you go through this and you eliminate them. Before you even write the claim, I would suggest you go through here and figure out which ones you're going to use based on the information that you have. Now, a lot of you use number 1, and I'm going to cross it off. Now, if you use number 1, any moving object has KE. I didn't necessarily take points off, but it didn't necessarily help you either. And the reason for this, it just says any moving object has KE. All the diagrams had KE. So this really wouldn't help you at all. They all had KE. Now, if you had one that had no KE or the KE wasn't in existence, yeah, then it would help you. But they all had KE, so this doesn't help you at all. Same thing here, number 3, any elevated object has gravitational energy. So we were looking, if you remember, the ball had 3 positions. And so you were looking at that 3rd position. So other than the one right here that was touching the ground, all these had elevation. All of the diagrams that you had, energy conversion diagrams, had elevation. That's why this one doesn't help you at all. Now, does number 2 help you? An object's kinetic energy increases as its speed increases. Yeah, remember there was arrows in between here. And this told you as it was falling, it's gaining speed. Why? Because the mass stays the same. So if the speed increases, that means the KE has to increase. And you might say, well, they all had KE, but only 2 of them had KE that was increasing. And likewise, number 4 is a good one because as it's falling, the GE is decreasing, getting smaller. Why? Remember, because it's losing elevation. So as an object's gravitational energy increases, now in this case, it's going to be decreasing because its elevation is decreasing. Remember, we talked about the opposite is also true. So this would tell me that, and remember, if you look at the diagrams, only 2 of them had GEs that were decreasing. So we know right now that number 4 is good and number 2 is good. 5, energy can be converted or transformed. All of them have energy that's being transformed or converted is the word I'm looking for, because they all are switching between KE and GE. It's just if it's dropping, it eliminates 2 versus if it's going back up. Now, any deformed rigid object has elastic energy. Now, before we dismiss this one, I'm going to explain why this is good. Remember, 2 of the charts that you saw And if we back up, we can take a look at it. Let me find it here. So let's look at it right here. So remember that two of these had elastic energy. So by looking at any deformed object has elastic energy, we know that position 3 is not at the bottom. So as a result, we can take a look at 6, and 6 is huge because it helps eliminate two of them. Helps eliminate two of the choices right away. Now an object's elastic energy increases as its deformation. It's not touching the ground. So this has nothing to do with what we're doing. 8, energy can be transferred between systems. This is all one system. It's just a tennis ball dropping. So we're not talking about energy transferring into the air. And then energy cannot be created nor destroyed has nothing to do with what we're talking about. So again, before you even write your reasoning, I would go through the scientific principles. If you have a computer, use the strike through button, or highlight the ones that you want to use, because now I know 2, 4, and 6 is what I want to focus on when I write my reasoning. So here's my reasoning, and what I did is I put different parts in different colors and I alternated the colors so you can see. So notice I don't just list the scientific principles. A few of you just copied and pasted the scientific principles and you just pasted them there and that was it. You had nothing else. Now, one of the reasons why we like having these tests on a computer is because you can copy and paste the scientific principles. It makes it a little bit easier than having to write it all out. Now, whenever you talk about scientific principles, I would say scientific principles or SP number 2, because that draws the readers, and I'm the one who's reading it, so it draws my attention right to it. Because sometimes you talk about it very vaguely, the scientific principles, and I'm left wondering, are you really talking about the scientific principles or are you not? But in this one, I know this person right here who wrote it, and this is mostly a student's work. It says scientific principle SP number 2 states that an object's KE. Now I added this part right here because I'm telling you, you don't have to write scientific principle out every single time. So I did shorten it for the person who wrote this. So scientific principle number 2 states that an object's KE increases as its speed and or mass increases. Now I didn't just leave it there. I have to explain why that takes my evidence, and it takes that evidence and uses it as support for my claim. So in this case, the closer the tennis ball gets to the ground, the faster it will go as the GE is being converted to KE. The mass of the tennis ball does not change, so the KE must be going up. So you notice how I said the mass of the tennis ball does not change? That's important. Because if it's dropping and the mass is changing, maybe the KE is not going up. But because the mass isn't increasing, it's staying the same. And if it's gaining speed, the KE must go up. So that's, I fully explain. If you watch that, I talk about this and I come back and I fully explain what this has to do with my evidence and how it supports my claim. We also know, according to scientific principle number 4, that the GE of an object increases as its elevation and or its mass increases, and that the opposite is also true. As the tennis ball drops, it is losing elevation, and thus the GE decreases because the mass does not change. Again, do you see how I write out the scientific principle? And I explain how this scientific principle ties my evidence to my claim. I don't just list it, I explain here, as the tennis ball drops, it is losing elevation, and thus the GE decreases. Again, as long as mass does not change. I have to explain what it has to do with my evidence, how it connects my evidence back to my claim. So here's my third one. Diagrams number 3 and 4 are also wrong because scientific principle number 6 says that any deformed rigid object has elastic energy. At position 3, the object that is falling is not deformed and thus has no EE. So again, I'm explaining why scientific principle number 6 links my evidence and links it back to the claim as supporting it. Finally, we know that there is about 50% KE and 50% GE because the object is halfway between its peak height / speed and its minimum height / speed. Now, did you really need to have this? No, because there's more than enough other evidence. Therefore, now this is my concluding statement. A lot of people forget about this. you don't mention your claim at all. So if you look at the rubric right here, states proper scientific principles. These were the ones I was looking for, but includes a generalization that energy diagram number 2 is the best example and restates claim. So here it is. Therefore, according to the above scientific principles, I know that energy conversion diagram number 2 is the best choice for tennis ball at position 3 in the diagram. So that concludes it. So don't forget to restate your claim. So this does finish up this video. As always, if you have any questions about reasoning, if you think I made a mistake, if you want to go over it with me, you're always more than welcome to show me what you have, but you need to come in. Don't just email me and say, hey, I think you made a mistake. I need you to come to me and say, this is the mistake you think I made. Otherwise, I really don't know what you're trying to get me to look at. And make sure, as always, if you have any questions, ask your teacher. Thanks.